Thanks a lot for inviting me. I'm really honored to be able to discuss with you. I'm working on the policy challenges in the deployment of carbon dioxide removal methods. So basically what I want to explore is how do we make these mitigation pathways come true, starting now in the coming decades. I understand that I don't really need to introduce the role of CDR and BECS in mitigation pathways or CDR methods. So that's cool. I will go directly to my the rest of my presentation. I want to talk about two things. I will very shortly talk about a first important policy challenge in deploying carbon dioxide removal, and that is creating economic incentives for CDR. And then I will talk a bit more on work that I've done recently on international cooperation and its role to reduce the cost of carbon dioxide removal. So first of all, today, the economic incentives that are available for carbon dioxide removal are very limited. And we can separate two categories of activities in that sense. The first are activities for which carbon dioxide removal is actually a co-benefit. So there already exist economic models, for example, in terms of agricultural interest, improvement of soil quality, for example. And these existing values can be reinforced for their co-benefit of carbon dioxide removal through voluntary carbon credits. So these voluntary carbon credits, they already exist, and the prices that we need to reach for to make these economic incentives sufficient are not as high as for investments that are dedicated solely to carbon dioxide removal. And in this category, I consider DACs, which is a process that wouldn't exist if we didn't want to remove CO2 from the atmosphere, but also BECS, because the only reason for adding CCS to a bioenergy process is to achieve carbon dioxide removal. And this carbon dioxide removal, this is still an externality, currently a positive externality that is not included in any carbon tax, carbon markets that is institutionalized. And so there is a need for public incentives, private incentives to create economic incentives for these technologies. So in terms of public incentives, there are already a few initiatives happening, and the form of these incentives, of course, have to vary depending on the maturity of the technology. So in terms of innovation and R&D subsidies, there are currently initiatives within the Innovation Fund in Europe through the Net Zero Industry Act. So it's already possible for some CDR processes, especially those that use CCS, to get access to R&D subsidies through the Innovation Fund. Then we have outcome-based subsidies, such as the Swedish BECS reverse auction. So if I remember correctly, they made a reverse auction for 2 annual megatons of CO2 removed from the atmosphere. And it's one BECS project in Stockholm by Exergy that won this reverse auction, and that will be subsidized. Then we have tax exemptions. That's the strategy that's used by the US with the 45Q and the Inflation Reduction Act. And we have, on a longer term, the possibility to include carbon removal credits in emissions trading systems. So that is not yet included into existing policy, but some academic propositions have been made on how we could include carbon removal credits into the European ETS, for example. And I know that, for example, Ottmar Edenhofer did make a presentation at the expert group on carbon removal certification in Europe to present these propositions. So maybe we will see in a few years a more serious proposition to include carbon removal in ETS. But there are a lot of challenges associated with that that are really interesting to investigate before. So these public incentives, they exist, but currently if you talk with investors and people who are starting to work on carbon dioxide removal processes, they usually primarily need work on private incentives, exploratory investment, but also voluntary common markets. And there again, there are many interesting questions to explore on how these common markets work, how we can make sure that we have a more credible and viable access to voluntary common credits in the future. And we will be starting a PhD topic on this at Centrale Supélec with Stellantis starting in January 2024. All these incentives, they will benefit from the creation of standardized certification frameworks for carbon dioxide removal, simply to ensure that we can have trust that carbon dioxide removal methods actually do remove CO2 from the atmosphere and do not have negative impacts on the environment, on people in their implementation. So currently there is a process going on in Europe with the Common Removal Certification Framework. Their expert group started in March 2023, and just a week or two ago, they had a meeting on what they call industrial removals. And there is also high hopes being placed on Article 6.4 of the Paris Agreement, who should be giving guidelines on how to treat carbon removals within this international common market that is being defined under Article 6 of the Paris Agreement. And this should give an example that can be followed by other voluntary common markets. So it's really important at the coming COPs that good standards are being defined within Article 6 for removals, so that it can give a good example to follow for other carbon markets. Another important policy challenge in deploying carbon dioxide removal is the question of international cooperation. I heard in previous presentation the importance of international trade in reaching mitigation pathways. What we found interesting here to investigate is how to ensure that international cooperation can actually happen. So first of all, the cost of carbon dioxide removal could, if we go to the levels of CO2 deployment that are projected, could reach very high levels. So some estimations have assumed up to 4% of annual GDP that would be that CDR investment would represent by 2100. So reducing the cost of CDR will be essential here. And in addition to that, countries have common but differentiated responsibilities towards climate change, which means that countries with considerable carbon dioxide removal potential and therefore lower cost may not be incentivized to invest in CDR. So one first question we had here in this joint work with colleagues from Imperial College, Solène Chiquier and Naël McDowell, and my former PhD supervisor, Olivier Massol, was to first investigate to what extent cooperation can reduce the cost of carbon dioxide removal before we evaluate how this cooperation can happen. So we chose 4 regions: the US, Brazil, the European Union, and China. These 4 regions represent more than 50% of global cumulative greenhouse gas emissions between 1850 and 2009. And they also represent a very diverse set of historical and geographical situations. So even if we didn't have data on all regions, we hope that this is representative enough. And each region was supposed to get a long-term carbon dioxide removal target that is in line with its historical responsibility to its climate change. And then we looked at 2 extreme scenarios. One where each region reaches its own carbon dioxide removal target on its own, only with domestic resources. So that would be the standalone scenario. And one scenario that we call the Grand Coalition, where all 4 regions put their CDR target together and deploy CDR cooperatively to reach their joint target of 214 gigatons of CO2 cumulatively by the end of this century. So to evaluate the cost of these different scenarios, we used a modeling framework that has been developed by my colleague Solène Chiquier, and it's called the Modeling and Optimization of Negative Emissions Technologies, MONET. It takes a set of spatial and temporal data sets and looks at the deployment of 3 CDR options, which are afforestation, BECCS, and DACS. Solène also deployed other options, enhanced weathering and biochar, but we didn't include them in this study. We minimized the cost to reach each of these CDR targets under our 2 cooperation scenarios, subject to these different technology choices: BECCS, DACS, and afforestation and reforestation, regional CO2 removal targets, sustainability constraints, CO2 storage constraints, and CDR deployment constraints. And as expected, we see an important cost reduction when cooperation is allowed. And in terms of total discounted cost until 2100, we found a 57 cost reduction when cooperating. We see as well that without cooperation, DACS seems to be used as a last resort option for the US and Europe. And when cooperation is allowed, BECCS and afforestation are being used in priority, which is understandable considering the higher cost for DACS. We also see here the size of the pies indicates how much CDR is being produced in each region. And we see that when cooperation is allowed, there is less CDR being produced in the US and in the European Union, and more in Brazil and in China. So the second question here is, under which conditions these 4 regions will accept to cooperate? And to look into these questions, we use concepts from cooperative game theory. And we verified 3 conditions to ensure that these 4 regions can find a way to share the cost of CDR in a mutually acceptable manner. The first condition is efficiency. All the costs have to be distributed, no more, no less. The second condition is individual rationality. Any individual region should be able to reach their carbon dioxide removal target at a lower cost by cooperating than by standing alone. And group rationality ensures that any subgroup of regions should be able to reach their aggregated carbon dioxide removal targets at a lower cost by cooperating by the remaining other regions. And in cooperative game theory, the set of cost-sharing vectors that verify these conditions is called the core of the game. And we use here the amount of cost reduction that can be achieved by each region within a mutually acceptable agreement as a proxy for its bargaining power. So if one region can reduce its cost much more and even get a positive benefit from cooperating in CDR, we will conclude that they have more bargaining power here in this agreement. So what we see here in gray is the ranges of cost allocation for each country that would be mutually acceptable. If the costs are higher or lower for each of these regions than what is displayed here in gray, then cooperation would not be possible. So we see that Brazil and China have to get a negative cost, and they get a significant cost reduction or benefit here that illustrates their bargaining power in working with European Union and the US. And it's still rational for the EU and the US to organize financial transfer towards Brazil and China, because then they get access to cheaper carbon dioxide removal. So basically what we wanted to illustrate here is that countries that have higher resources for carbon dioxide removal and lower responsibility towards climate change have important bargaining power in cooperating with other countries who have maybe a higher ambition but less access to CDR resources, relevant resources. So the Paris Agreement could be an option to organize this cooperation, and upcoming discussions at COP28 in Dubai should confirm how carbon removal will be defined and treated under the Paris Agreement. So here I put some ongoing projects and previous publications, and yes, I hope you enjoyed the presentation.